All right. Well, it looks like most everybody is it's slowing down. People coming in. So first off, welcome. We're so glad that you're here with us this afternoon for this next Lunch and Learn. Today, we're going to be working through the new Emlid base station or a GNSS receiver that they have available that is a big part of the drone program at Kuker-Ranken. I really like this product. I happen to have one myself. Brady, I don't know if you knew I had one of these.
Oh, I did not know that.
But Brady is a virtual design consultant. Brady is a virtual design consultant at Kuker-Ranken and has a tremendous amount of background using various GNSS systems with drones. So Brady, I'm just going to hand the whole room right over to you and have at it.
Wonderful. Thank you, everybody, for coming. Really appreciate it. And I guess we'll just start diving into and looking and seeing what we've got to offer today. So I'm going to first share my screen. Here we go. And everyone should be seeing my PowerPoint come up.
Confirmed.
All right. Wonderful. Thank you so much. So yes, today we are going to be talking about the Emlid RS2, which is a multi-band RTK system that we like to pair a lot with basically drones. And that's what we're specifically talking about today. So a little bit that I want to go over before we jump into the Emlid is, who am I? Why am I the guy talking to you? So Douglas did mention this a little bit earlier. I am the virtual design and construction reality capture specialist at Kuker-Ranken. It's a very long title, so I apologize. We like to shorten that up to VDC reality capture specialist. Makes it a little bit easier to digest. Again, my name is Brady. I am a CFR 14 Part 107 certified SUAS pilot. I've had a lot of background in architecture and enterprise support, specifically with drone systems. I am also a drone instructor with Sundance Media Group, and I am basically one of very few, along with Douglas as well, as a Pix40 instructor who is actually not inside of the Pix40 realm. So we're able to teach the system, and we're certified to be able to teach all those different types of programs. So before I jump into my next slide, I actually want to bring up a finalized product here. Looking at my taskbar, here we go. So we're going to discuss, there's a couple different things that had happened during this flight and what we're actually doing to correct it. I just wanted to point out.
Brady, pardon me for jumping in.
Yes, sir.
You just said Pix4D, but that looks like Lica Infinity.
This is Lica Infinity. Yes, we're going to be going over both systems. So the backbone, they actually run very similarly, and they use a lot of the same code that's available. It really depends. Sometimes you want to use one or the other. In this case, this is just the program that I've got pulled up, so we can go through all this. So you are correct. This is Lica Infinity. Thanks for pointing that out, Douglas. So we can see we have all of our capture from our imagery, and we will explain what had happened on this very first row. We were able to get this very, very tight within about a thousandth of accuracy, and I'll explain what had happened here. But because we're able to tie all of those points together that we had taken from our ground control points, or GCPs, excuse me, we were able to make this very, very accurate and just a fantastic model. So I wanted to pull this up and show you kind of a finalized what had happened after we had done all of our flights. So let's go ahead and jump back. We're going to jump into a little bit of the technical side of it and specifically talk about the reach, and then we'll go back into this project afterwards. I just want to give you a heads up. We're not done with the project just yet. All right, so back into the PowerPoint here. So we have our Emlid RS2. So this GNSS receiver has centimeter accuracy within 60 kilometers using the RTK, or the real-time kinematic, or within about 1,000 kilometers using the post-processing kinematic. We'll dive into those just a little bit and kind of what the differences are here in just a few moments. So with this receiver, we are able to look at GPS, GLONASS, Baidu, Galileo, and QZSS. So typically the big ones that you likely have seen is the GPS, GLONASS, Baidu, and Galileo. This is also 16 gigabytes internal storage. So as we have points or information, the actual unit itself has storage. So we don't have to use an auxiliary device such as a phone or any sort of an SD card, or even a USB drive. It is IP67 rated, so we are able to use this in very rugged terrain and different weather environments. So we are able to utilize this. Unfortunately, we can't always plan for the perfect weather to always fly our drones and get the information we need. However, if you do run into any of those storms, you can rest assured that the actual receiver head will just be fine itself. So no problems there. So we can operate within about a -20 Celsius to 65 Celsius operating temperature. So it's a very wide range. We use it here in the desert quite frequently, and it works fine in the middle of the summer when we're sitting at about 110, 112 degrees Fahrenheit. So this uses several different transmission modes that are available. So we can use a TCP, LoRa, which is the little antennas that dangle on the bottom. That's basically a radio band from the head to whatever else you're trying to send the corrected signal to. You have Bluetooth, RS-232, or cellular. So there's many different options available for the Reach RS2. So we are going to be primarily talking about in-trip networks, so just getting your corrected data. And then this uses an RTCM3 protocol. This is a very standard type protocol that many different receivers are able to read from. And one of the other big things you might hear different things about L1, L2, and L5. This head actually supports the L5 band, which is it's incredible. And we'll talk about that in just another moment here. So hold your questions for just a few moments. First, we'll briefly touch on real-time kinematic and what this is, the RTK. So on our image, we have our GNSS satellite that's up in the sky. We have our signal coming down to basically the base station or into different networks that are available using SpiderNet, SmartNet. There's a lot of Utah VRS. There's different types of stations that receive these corrected or basically these satellites and then give the corrected signal to a specific system, and then it relays that information to the drone, right, or to what we refer to as the rover. So it's very high positional accuracy in real time. So this happens right away. So this does require a network of some kind. In our case, we are going to require that there is some sort of either a cellular or Wi-Fi connection to the head to provide that network to be able to send over the internet to the rover, which is our drone. So we are using GPS, GLONASS, Baidu, and Galileo. And this is based on the L1, L2, and L5 bands. So real-time kinematic, this is something where it gets instantly sent to the drone, gets updated, and as soon as we put it into different systems like Lica Infinity or Pix4D, we already have corrected data on the imagery. So the next piece I want to talk about is the other hand. What if we don't have a network? Well, you still have options. This is called post-processing kinematic. And what this does is, again, you've got a base station or a network that is constantly observing all the different constellations and gathering the information. And then it stores that information into basically a specific file, which we're going to be talking about RINEX here in just a moment. And with that file, you then take that the imagery from the drone and the RINEX file from the drone, and you're correcting where the drone was after the fact. So this is not real time, this is after the fact. So high accuracy post-processing or after the capture. There is no network that's required because everything is saved locally, so you don't have to worry about it. So this again looks at GPS, GLONASS, Baidu, and Galileo. Again, we've got different systems, the L1, L2, and L5. And one note here that with a post-processing kinematic, this is going to take a little bit more effort on your end to process that data to get the corrected information. So just be aware that this is a little more intense, but it's still possible to gather corrected data. And if I can skip it, there we go. So L1 and L2 are basically bands that give that corrected data. L5 is still fairly new. There's not a lot of satellites out there that support the L5 band, and the heads, of course, are coming as well. But that L5 band, as it reads out here, is basically provides additional robustness in the form of interference mitigation. The band being internationally protected, redundancy of existing bands, geostationary satellite augmentation, the ground-based augmentation, and added robustness. This band also benefits from terrestrial applications. So really breaking it down, it's great for high positional awareness in high interference areas, such as vegetation. So if you're trying to go below trees or in a high-rise urban environment, the L5 band is a fantastic option. So just as a little illustration, we've got our image here. So with the single frequencies, basically with the L1, it's shooting all the information down to the automated car that's driving here. And we see our accuracy is pretty wide. So as we use dual frequency with that L1 and then also with an L5, it's actually taking out some of the other corrected data, because as you're looking at the image, it's bouncing off of windows, reflective surfaces, things like that, to cause inaccuracies within its positional data. So the L5 really cuts down on that a lot. All right. So the next thing I'd like to go ahead and cover with the Emlid specifically is the Emlid caster system. This is an online-based caster website, essentially, that you can use for all of your RS2 heads. And what this does is that it'll take all the information from, if this head is sitting on site as I want to go through and fly my drone, I usually keep it on a surveyor pole and a bipod, and we'll talk about that in a moment as well. But we'll leave this sitting out, and what it's doing is it's gathering the information, observing the sky, and seeing where it's at, right? Then what's going to happen is that I've got this set up with a SIM card, so we'll update over the internet this data to the caster website from Emlid. And with that system, then I can connect my drone as my rover, and that's going to be the next slide. I'll give you a little more information on it. But we can have up to 5 mount points for free. So it's a free service by Emlid. It's fantastic to be able to have its own casting network to broadcast that system. Then we have rovers. So with rovers, we can have up to 10 connected rovers at a time using the same Emlid website. So the rover uses the data from the corrected network or from the base station to achieve the precise positioning in real time. So on the illustration, we see there's a head sitting down, and it's got these blue lines that are going to a bunch of different things here. So as we call them rovers, these can be many different things. It can be boats, cars, planes, drones, many different things. In this case, we're specifically talking about the drone. So this is our rover. So we can then go onto that website. It will show me what is online. Right now it shows offline 0 because it's screen capture, but we'll be able to look at this live and see what this is. This will give me my information I need to input to allow me to basically update the drone, because the drone asks me for the address, port, user, password, and the mount point. And then the last thing I want to cover right here before we start diving into some of these applications directly is the Emlid Studio. This is specifically for your post-processing kinematic or the PPK workflows. So as we've got our image here, this is going to be a desktop-based post-processing application. I can have this on my laptop out in the field. I can gather all my information and then put it onto that application on my desktop and run it, regardless if I had internet or not. So in the field, I can get real information to say, yes, this is good information, or no, I need to go back and recapture for some reason. So this will process the rover data or the drone data with the base data and the navigation file within the Emlid ecosystem. You can also average your points when you're using the ReachView 3 application, which we're really not covering today, but there are a lot of different options with this receiver. And you are able to convert the Rhinex file with more advanced settings rather than just drag and drop if you're an advanced user. And then most RTK aircraft, such as the Evo 2 RTK or the Phantom 4 DJI, the RTK, offer the Rhinox format output, which can be imported into Emlid. So that brings up basically what is a Rhinox? We keep talking about some of these different things and how this works. So it is a receiver independent exchange format. It's basically I would call it a universal language, so that all different types of systems, drones, cars, the heads for the Emlids, or even for Leica GS18s. The Rhinox file is just something that allows things to be seen universally between multiple programs. So what I would like to go ahead and pull up next for you is directly on our Caster website. So I have just signed into the caster.emlid.com. Very easy to do. Again, like I said, it is free. We have different mount points. So I've got 5 different options that are available to us using this free account. And right now, we only have one turned on. Right now, it is offline, which means it's not actively connected because the head is currently turned off. I'm inside. It's not going to do me any good when it's inside. So we've got different address, port, password, and mount points. And we can scroll down and we can look at our rovers. So if, for example, our RS2 was turned on and our Evo 2 Pro RTK was turned on, we would show one online from my rovers, because we put in all this information for our drone, and it will then connect to that network as long as my RS2 is online as well. So this can be viewed on a desktop or on your mobile device. So very simple to get in and out of. And the next thing we want to cover is our Emlid Studio. So I'm going to close out of this and show you how easy this is to use. Here we go. And I'm going to get rid of my files I created earlier. Here we go. So after we go through and fly our drone, we've got some information that we can process. So from our drone, right, the Evo 2 RTK or even the Phantom 4 Pro RTK that we have, there's an output of a Rhinox OBS file. So this is for our rover, if you remember. So we're going to take this file, we're going to drag it to our rover spot. Now we have our antenna height. Right now, the drone consistently changes, so we're really not able to modify this. But we can go in. Now we have our KR demo reach. I'm going to put that onto my base here, which is a UBX file or a Rhinox. We are now converting to the Rhinox file, and I need to set my antenna height. So right now, with our receiver, look around my camera, we've got the RS-RS2, and we set this up on a 2-meter pole. So we'll save. And then,
Brady, if I can interrupt real quick, you've got all those files up there in the upper right-hand corner. You're saying those are coming from the drone. Where does a user find those files?
So so great question. The 101 ftask_rhinox.obs file. This is directly from the drone itself. This can be either found on the internal memory on the Evo 2 Pro. It does have about 8 gigabytes internally that you can utilize. You plug in a USB-C cable to your computer and download that. Or it could be written to your SD card, which is on the other side. It really just depends on what settings you have set up through the Autel app. And with the Phantom 4, they're all going to be saved onto that micro SD card. And that is specifically the 101 ftask, which is the actual mission for that drone. The other 2 files we have in here, and I should have pointed that out, you're correct, the 201p file and the UBX file. These are files that have been downloaded directly from the head unit, basically showing that this is our base we're trying to convert from. Does that answer your question?
Thank you. Yes.
Okay. So we'll go ahead and continue and throw in our 201p file into our navigation. And now we have a process button we can select. And we're just going to let that run for a moment. So you can drag and drop all your information here, and this is going to process. We will see down on the progress bar, we have a little bit of a float and then a fix. Well, that doesn't make sense. We want to make sure that everything is fixed as much as possible. So that means that at some point as we were flying, we weren't getting a solid fix to the drone with that information. So once this processes, maybe we'll get some more information. Oh, there we go. Makes perfect sense because I was the one who went through to fly this. I know which direction it happened and where, what happened in the situation. So very first thing, we've got our green on the top left here. This is where we started coming back down north to south. And then we have a lot of orange here for floating because it wasn't quite fixed appropriately, which means either we lost some sort of a communication, there's a communication error between all the components that we were utilizing, or maybe someone had gone through to touch the pole as this was trying to capture and grab a fix to the data. So it can't send a fixed signal if there is no fix. So we lost it. We got a little bit of float, and then we come back and we see everything else green from south to north and back down and doing our pattern like we would expect a drone to do. And we had a fix for the rest of the time. I specifically know this because I had a little 3-year-old touching the pole for just a slight moment, which is why we got a little bit of a float. But we can go through and correct this, which is why I wanted to show you inside of Lica Infinity. So we have this updated information now, and we can then put it into different programs to update the imagery to ensure that everything was shot where it was supposed to, or it's processed appropriately. So I'm going to pull up our Lica Infinity again. And we can see all of our imagery here. Now, on my imagery, I see everything is nice and straight. That just means that the drone itself was flying correctly, so there was no wind or anything else that was causing any issues. It was simply the transmission from using the system to the internet, or from the internet over, or someone touching the pole and slightly moving it before it got its fix back. The good news is we went around and got a couple control points around here. So we've got our 001, 002, 003, 004, and 005. And we were able to correct this data and get within about a thousandth accuracy. So very, very good. Even though we had a float for part of the mission, we are able to correct that data. And when we go through and post-process and then putting it through Pix40 or something like Lica Infinity as well. So I'm going to go ahead and jump back into our PowerPoint here. So drones and the Emlid RS2, right? So what exactly do we need? Well, number one, you need drones, right? It really depends on which kind of a drone. There's lots of different reasons why you would use one or the other. There's the Evo 2 Pro RTK or the Phantom 4 RTK to get that data. And if you wanted to get more into that to see which one will work best in your situation, make sure to reach out to us and let us know. We'll have a specialist come in and talk to you. There's also the Emlid RS2, the head itself, right? We need this in order to process that data. So that type of a head, we've got other heads here, but we're specifically talking about the Emlid. So where does the Emlid sit? What do we do with it? Well, we need to have some sort of a pole for it to sit on. So in the back here, I've dropped this down a little bit. So we have our surveyor pole here that we do sell as a kit all together. And then we also have a way for that pole to stand up straight, right? So we have a bipod sitting over here to make sure that everything is standing up straight. This is something with the Emlid RS2, it does not support any tilt functionality like some other receivers, such as the GS18s, which is not the end of the world. That's just another feature that you're not able to utilize. So we need to make sure that everything is nice and steady and secure. So having a surveyor pole and a bipod, make sure that unit is not going to move unless you have kids and they like to touch the pole as you're moving. And then last, of course, we've got different processing softwares like Infinity or Pix40 are preferred services, and we are able to teach you how to utilize all those systems as well. So with that, I know we're running close to our time, and I just want to see if there was one or two questions that we could answer real quickly for you.
Brady,
Douglas,
we've had a couple questions come in. One important one is power is everything, and we're often out in the field away from things. So what's the battery life, and what are the charging requirements when we're out in the field?
Absolutely. So with the Emlid RS2, it's an internal battery, and it is rated at 22 hours of continuous running time. We are able to utilize a USB-C cable to plug right into the bottom. They've got little rubber ends here. We can open this up for the USB, and we can just plug that directly in. It can be plugged in while it's running or just simply to charge. So you can charge it off your laptop, off of a typical USB charger, or in your hotel room or in your car.
Excellent. There's another question here. What's the cost of the Emlid Studio system?
So the Emlid Studio system is actually free. No cost. It doesn't cost you anything for that system. There may be advanced features coming out in the future, but as of right now, it's a free system.
Outstanding. One of the questions that was just asked by James is if there's any info on the Mavic 2 for the Phantom 4. Oh no, I think he means the RS2 for the Phantom 4 Pro and adaptive kits for PPK. I think, well, I'll just let you answer that one.
There are adaptive kits that you can use for a Phantom 4 Pro non-RTK model. They're a little bit more cumbersome, and just be aware that adding additional things to your aircraft, right, that are not specifically from the manufacturer are going to start draining the battery a lot faster because you have to power it somehow or carry more batteries. Thus, you have more weight, and could cause additional flight characteristics that are not something you want to have. However, they are possible and they are out there and available as well.
So yeah, there's the M2 that can be attached to the drone via Velcro or something like that, if that's how you want to use it, James. And so that'll give you the capability of RTK on there. You'll need to understand that if you use something like the M2, you're always introducing a little bit of error, simply because of the fact that, let's say you had this. I don't have a Phantom in front of me, but the M2 is going to sit up here on top of the aircraft, and there is a distance between the M2 receiver and the lens of the camera. So your data is not going to be camera centered, which means that you've already built in a little bit of error that you'll just have to correct for and be aware of later on. So there we go. Yeah.
There we go.
And
thank you.
In the case of the RTK model, however, the Phantom 4 RTK, the lens position is compensated for in software. So the RTK antenna and the lens are compensated for together. Brady, one other question just came through on my Fletcher. Yes, Kuker-Ranken has got survey poles and bipods, and there's even a bundle that Brady can tell you about. But right now, I want to ask one question, Brady, that just came through. So I've got an Autel Evo 2, you can see here, no RTK. Is there any benefit to me at all having this unit alongside my aircraft, or do I have to have the RTK system for there to be of any benefit?
Oh, you absolutely have a benefit. So remember, when we have something like the top hat on the top, we are getting real-time updated information. What we can utilize this system for is to go out and mark our points on the ground for our ground control points. We're still taking the images. And then when we go through and process through Lica Infinity or through Pitch 4D, we can set these points as my ground control point, and then take all the images that where the drone thought it was up here, and I'll correct that data basically on the images. So you're not updating the position of the aircraft in real time. That's processed, but it's not considered post-processing. It's not PPK method. That's slightly different. But you would have absolutely a benefit to utilize both those aircraft, even if your drone doesn't support RTK, because you can pull your points down with that the GNSS receiver.
Excellent. Okay. Well, Brady, I think we're we ran out of time here. You're even 5 minutes over, but we want to thank everyone for attending with us today. And if you have questions about any of the products or et cetera, you can find Brady at the Kuker-Ranken store in Las Vegas. And of course, there are stores in Salt Lake City, Seattle, Boise, Tacoma, Portland. I think I mentioned Las Vegas, so we've got all the stores there. Needless to say, Brady, thanks for your time. Thanks for everyone who attended. We're grateful for you taking the time to be with us. The next event that we'll be having is on December 8th with Stuart Snyder. He's going to be doing an introduction to the DT research RTK and scanning tablets that are available using tools like Dot3D. And the week following is Adam Huff. Adam will be presenting an introduction to a series, and that series is the Lica BLK to go and mobile mapping. And that's actually a full series. It's not just a single webinar. So we'll look forward to seeing you at both of those. And then for 2022, we've got some really exciting things coming up as well. The December 15th event with Adam Huff on the Lica BLK to go will be our last lunch and learn for the 2021 calendar year. So we'll look forward to welcoming you in January. But needless to say, we've got 2 more events to welcome you to. And thanks again, everyone. Have safe travels and happy measuring. Thank you.